Hello, welcome to Formulaic Fun. My name is Sarah. Here we look into math problems and learn how to investigate math in fun and creative ways. Today, we have a few questions that we wish to answer. So we're going to start with, what is the volume of $1 million in stacks of $100 bills, and what container could possibly store this $1 million? After we answer those questions, we will then be answering how many 50-foot standard boxcars would it take to store and transport $1 trillion in stacks of $100 bills, and how many miles would these train cars span? So first, we need to start with understanding all of the dimensions of our math problem. So first, we're going to begin with the volume of a stack of $100 bills. This information comes from the LasVegasSun.com. The way that we're going to find the volume of this stack is we're going to take its length times its width times its height. So the length of a stack of $100 bills is 6.14 inches. Its width is 2.61 inches. And its height, the height of a single $100 bill, is 0.0043 inches. And since we have 100 of those, we're going to multiply that number by 100, giving us a total of 6.89 cubic inches of volume per stack. Next, we have the weight of a stack of $100 bills. This information comes from the omnicalculator.com. So we have we have 100 bills times the weight of each individual bill, which is 1 gram, giving us a total of 100 grams. Next, we have the volume of an average 50-foot standard boxcar, its inside dimensions, and this information comes from csx.com. Once again, to find the volume, we're going to take the length times the width times the height. So the length of this boxcar is 607 inches, its width is 114 inches, and its height is 131 inches, making this a total of 9,064,938 cubic inches of volume. Next, we have the length of the 50-foot standard boxcar's outside length. Once again, this information comes from csx.com. The outside length of the boxcar is going to be 665 inches. Next, we have the max capacity weight that each one of these 50-foot standard boxcars can actually transport and carry. That information also comes from csx.com. And each one, on average, can carry about 70 tons, and that's going to equate to 63,502,931.8 grams of total weight that each one of these boxcars can carry. Finally, we have the average distance of the railroad coupling. So that's going to be the distance in between each one of the two boxcars. Okay, this information comes from the Railwire.net, of which they say that there's an average distance in between boxcars of about 42 inches. Okay, so now we're going to start answering some of those questions. So the first question that we want to answer today is, what is the volume of $1 million in stacks of $100 bills? So first, we need to know how many stacks of $100 bills there are in $1 million. So how much money is in one of these 100 stacks? Okay, so we have 100 bills within the stack, and each bill is worth $100, giving us $10,000 per stack. So if we have $1 million, and we take that $1 million and we divide that by the total amount per stack, which was 10,000, then we're going to get, there are a total of 100 stacks in $1 million, where these 100 stacks are stacks of $100 bills, and there are 100 of them. So, therefore, the volume would be 100 stacks times the 6.89 cubic inches per stack of volume, giving us a total of 689 cubic inches of volume for $1 million. Okay, so now what container could actually store that $1 million? Well, all we need to do is we need to simply find a container that has a volume that is larger than 689. So through some research, I found that a large USPS flat rate box has inside dimensions of 12 inches, 12 inches by 11.75 inches by 5.5 inches. So let me go ahead and grab this box so we can see what this looks like, right? So this is that box, and we can see it's fairly small and compact, and $1 million would easily fit into this box, okay, which is pretty impressive and pretty surprising for most of us. So when we see all of those movies where they have $1 million in a briefcase, it's actually possible. Okay, so let's move on to our next couple of questions. Okay, so the next question we want to answer is how many 50-foot standard boxcars would it take to store and transport $1 trillion in stacks of $100 bills? Okay, so in order to answer that, we first need to know how much money could be stored in one single 50-foot standard boxcar. Okay, and this is in terms of volume. Okay, so if we take, up here I have all of that useful information that we saw 2 pages ago. Okay, so here, this number is going to be the volume of a 50-foot standard boxcar, okay, which was 9,064,938 cubic inches. And we're going to divide that by the volume of a single stack, okay, which is 6.89 cubic inches, and that's going to give us 1,315,665.8926 stacks. Okay, so if 1,315,665 stacks easily fit into a single 50-foot standard boxcar, then this is going to equate to 1,315,665 times $10,000 per stack, giving us a total of $13,156,650,000 per boxcar of cash that could fit. So, knowing this, how many boxcars are then going to be needed to carry $1 trillion if each boxcar can carry this amount of money? So we're going to take $1 trillion and we're going to divide that by the amount of money that each boxcar can fit, giving us a total of 76.0072 boxcars. Okay, we're going to be a little bit generous here and we're going to round down, okay, and just say that this would take up 76 boxcars, and then move on to our final question, which is how many miles does this span? Okay, so if we have 76 boxcars, and we know that the length of the outside of each one of these boxcars is 665 inches, we're then just going to multiply those two numbers together to give us a total of 50,540 inches, or 0.7977 miles without railroad coupling. If we wanted to add in the railroad coupling, we know that there will be one less space, one less railroad coupling for how many of our boxcars there are. So if we have 76 boxcars, then that means there are going to be 75 spaces and railroad couplings in between these boxcars. Okay, so we're going to take the 75 railroad couplings and multiply that by the average distance in between, which is 42 inches, giving us a total of 3,150 inches, or 0.04 miles of railroad coupling. If we add those 2 miles together, this This brings us to a total distance of 0.8474 miles that $1 trillion would span if we were to put it into 50-foot standard boxcars and stacks of $100 bills. Now, at this time, you might be asking yourself, well, we did this with volume, but should we also be doing it with weight? I agree. We should probably also consider the fact that weight is important, right? If we have the weight where the stacks are less than volume, we would need to use the stacks associated with weight rather than volume, because we want to not only be able to store the money, but we also want to be able to transport it. Okay, so let's now think about these same two questions, but from the perspective of weight instead. So, how many 50-foot standard boxcars would it take to store and transport $1 trillion in stacks of $100 bills? Once again, we first need to start with how much money could be stored in one single 50-foot standard boxcar, now with respect to weight instead of volume. Okay, so we know that each 50-foot boxcar can transport 70 tons, or 63,502,931.8 grams of weight. And we're going to divide that by the total weight per stack, which is 100 grams, giving us a total of 635,029 stacks, where before we had a total of 1,315,665 stacks. So that means that we should use the weight stacks rather than the volume stacks. So now let's finish the calculations for weight. So if we know that weight-wise and volume-wise that 635,029 stacks will fit into a single 50-foot boxcar. This then equates to 635,029 times $10,000 per stack, giving us a total of $6,350,290,000 per boxcar that would fit with regards to both weight and volume. So, how many boxcars would then be needed to carry $1 trillion if each one can carry this much money? So, we're going to take $1 trillion and we're going to divide that by the amount of money that can fit per boxcar, giving us a total of 157.47 boxcars. Now, this number is going to be much closer in terms of rounding to 158, so this time we won't be as gracious. So we're going to say that in order to transport according to weight $1 trillion, we would need 158 boxcars to do that. Now, how many miles would this span? So, once again, we're now going to take the 158 boxcars, we're going to multiply that by the outside length of the boxcar, which is 665 inches, and that's going to give us 105,070 inches, or 1.6583 miles without the railroad coupling. Now, since we have 158 boxcars, that means we're going to need 157 railroad couplings, and we're going to multiply that by the average distance in between each one of those boxcars, which is 42 inches again. And that's going to give us 6,594 inches, or 0.1041 miles of railroad coupling. And now if we add all of those together, this is going to bring the total distance to 1.7624 miles that it would span in order to store and transport $1 trillion in stacks of $100 bills. Thank you so much today for listening. I hope you enjoyed it. Tune in again next time.